Okay, I'm going to go over this practice quiz for our chapter 3. It's only on 2 sections. So this is going to be the last quiz of the first marking period. So I'm giving you an opportunity to earn 50 points. So I'm going to make this quiz worth 50 points. We need to go into this quiz knowing how to solve quadratics. And right now we only know 2 methods. It's the square root method and by factoring. And I will let you know that number 1, number 4, and number 5 will have to be done using the square root method. And then the other ones we are going to factor. And that's how it's going to be on your quiz. So I'll tell you which ones need to be solved by the square root method. So with square root method, we're going to do the inverse operation. So like for this first problem, I need to undo subtraction. So we know to undo subtraction, we must add. So we have to add first so that we get 432. Before we can take the square root, we want to undo this 8. We can undo this 8 because it's being multiplied by x squared. I undo multiplication by dividing. Have a calculator. We can ask the calculator 432 divided by 8. It tells us 54. Now, I will remind you, anytime you take the square root, you need to remember that plus or minus. So I remember all answers. Soon as you take the square root of anything, you need to have plus or minus. So my next move then is to undo squaring. I'm going to write plus or minus root 54. Now, the directions will also say I want my answers in simplest radical form. So that's where you will need to know your perfect squares. I have a list of perfect squares on my sideboard. For 54, it's not a big number. Okay, so you could see, hey, well, I know 49 won't fit in, 36 will not fit in, 25 will not fit in. And again, how you tell, you could type in 54 and divide it by a perfect square. So if it doesn't divide evenly, it's not a factor. So the next perfect square, I tried 16. The next one on my list would be a 9. And when you divide 54 by 9, or if you simply know that 9 times 6 is 54, we can simplify this. So I need you to be able to understand 9 times 6 is 54. I now have my simplified answer. Don't forget the plus or minus, but the square root of 9 is a 3. So I say plus or minus 3 root 6. And that is my solution. Or that's the solutions. A positive 3 root 6 and a negative 3 root 6. Make sure you understand that. Okay, so I'm going to go down to number 4. I'm going to take care of all the square root problems first. So for number 4, I must take the square root right away. Okay, I can't subtract that 4 because of order of operations. I have to undo squaring. I take the square root, and it's going to be my job to know when I take the square root of 25, it's not only a 5, but a negative 5. So don't forget that plus or minus. And then the last move is to subtract 4. So really what this means, I want you to then simplify. You have 2 answers. You get an answer when you use a positive 5. 5 minus 4 is a 1. 1 is a solution. If you use a negative 5 and you subtract 4, you get a negative 9. Those are your answers, and it's really easy to check. If I would plug in a negative 9 into my original equation, inside parentheses, I would have to calculate negative 9 plus 4, which is a negative 5. And then when I square negative 5, I do get a positive 25. It checks. Same thing would happen if you plugged in a 1. Okay? Last problem with square root method is number 5. Don't panic. This is super easy to do. I don't care that that's a 2/3 in front. Okay, I'm going to do inverse operations. I'm going to first subtract 9. So when I subtract 9, we get a 10. Then I'm going to end up dividing by 2/3. Now you could multiply by its reciprocal, but I'm going to show you on the calculator that the calculator has no problem dividing by fractions. So it's very important, though, that we understand if I actually want to divide by 2/3, I must put 2/3 in parentheses. So it's simply 2 divided by 3. 10 divided by 2/3. Calculator tells me it's a 15. So x squared equals 15. Last step is take the square root. And since 15, there's no perfect squares. Okay, 16, of course, doesn't fit into it. 9 doesn't fit into 15. 4 doesn't. So there's my perfect squares. It's simply finished. It's in simplest radical form. Okay, the remaining equations we need to solve by factoring, and that is where we must have 0. So don't confuse the two methods. We just got done showing you all the square root methods, problems, and now we're going to go to factors. So you have to change your mindset. We now must have 0. So I am going to bring this 8 over, and as soon as I bring that 8 over, I am going to have my problem in standard form. In this form, I don't know the answers. Yes, you could check on the calculator. If you graph it, where across the x-axis will be your answers, but I want to see the factors. So I would want you to know, well, this is very easy to factor. It's x and x because that's the only way we're going to get an x squared. I need a positive. This number and this number must multiply to give you a positive 30, but I'm going to use a combination that adds up to a positive 13. So if you want to make a diamond, you certainly are a little x, you put the 30 up top, the 13 on the bottom. And so there's several ways of multiplying numbers to give you 30, but only one combination that'll agree with this 13. And that's going to be a 10 and a 3. 10 times 3 is 30. 10 plus 3 is 13. That's where I taught you that FOIL method. X times x is x squared. Your outers and your inners will add up to that middle term. We're not allowed to change the problem. 10 times 3 is 30. But once it's in factored form, then I know, hey, what makes this 0 is a negative 10. 0 times anything is 0. So negative 10 is an answer, and negative 3. That's the work I need to see on your quiz, okay? So then when you get to number 3, don't panic. This is that one that I promised you you're going to see. So you'll see a similar problem on your actual quiz where the number cancels out. You're left with just an x squared minus 2x in this case, and you can't panic. All you have to do is remove an x. Okay, and I included the last problem on this page that I simply added is just like this. So all I need to do to factor this, I remove an x. And now I can see the answers. What makes this 0 is a positive 2. What makes an x 0 is a 0. 0 is the solution. 0 and 2 would be where your graph is crossing the x-axis. So if you type this into your calculator, you'll see it's crossing at 0 at the origin and at positive 2. Okay? Nothing difficult so far. Number 6 is already equal to 0. So I'm going to set up my parentheses. It's a trinomial that I'm going to break up. I know I need a positive 20, but I need it to add up to a negative 9. So that tells me both numbers have to be negative. So I know I'm going to have x minus x minus. So ways of getting 20. 20 times 1, 2 times 10, and 4 times 5. And that's the combination that we need. So when we put a 4 and a 5 here, x times x is x squared. My outers, my inners will agree with that negative 9x. A negative 4 times negative 5 is 20. So if these are my factors, positive 4 and positive 5 are my solutions. Okay, and you can check on a calculator. I added this problem, just quickly added it before I printed this out, just to remind you. If you see a problem where there's only 2 terms, you have an x in common. You cannot solve this by the square root method. This cannot be solved by the square root method because it's a square term and an x term. You simply remove an x. It is now factored. If you distribute, you're back to the original problem. But then you should realize 0 is an answer and negative 9 is an answer. Okay, I want to see this though. So you're going to lose points if you don't show me the factors. So I want you to have that connection between here's my original problem, here's my factors, here are my answers. Okay? Hopefully that page you'll have 6 equations to solve on your quiz on Friday. Here is our revenue question. So you're guaranteed to have a revenue question. So it is so important that you get this part correct, because if you don't have this part correct, you're not going to be able to get this part. Okay, so you need to make sure you read this problem carefully. Okay, in our practice, we dealt with kayaks, we dealt with jeans, we dealt with sandwiches. It doesn't matter what the object or the item is. You will be given a price, and you'll be given how many people are willing to buy it at that price. So right now, our revenue is generated by charging $20, and at $20, we can expect 700 students to attend. Okay, so 20 times 700, that's our current revenue. But we want to see what happens when we increase the price by $1. So here's the rate in which we're increasing. It's a linear situation. We start out with $20. We read the word increase. So I'm going to add a 1x. Okay. Every time I increase it, I'm increasing it by $1. But then that has a negative effect then on the amount of students willing to pay to attend this. So we're told then, well, if you raise the price, every time you raise the price, you're going to lose 25 students. So you're going to lose. So it's minus 25x. There is your quadratic situation. It's 2 linears multiplied together, and you better make sure in your quiz, one has to be positive, the other one has to be negative. Okay. If they're both the same, you will never find a maximum. Okay. That means your graph is opening up, which means it goes up forever. We need to have a peak. And at this point is where I simply take my calculator and go to the y equals screen. So let me quickly clear this calculator. Second plus 712, second plus 722. So now when I go to my y equals screen, it is blank, and I'm simply going to type in exactly what we wrote here. Our $20, we're raising it by $1 each time, and then our number of students willing to pay will decrease by 25 each time. So it's a simple matter of typing it into your calculator and then go to your table. Second graph. If we don't change the price, our revenue is $14,000. If I increase the price by $1, it is now going up. I try $2, it goes up to 14,300. I keep going until I see the peak. At 4, when x is 4, we have 14,400. And if you would go to 5, you have to see that it drops. So my vertex, my calculator is showing x is how many times we're increasing the price by $1. And I found the vertex to be 4. And then my max revenue, the max is 14,400. So now the key is to answer these 3 questions. What should the school charge per ticket? If X is 4, I go back here. Now, sometimes this isn't a 1. Maybe we can increase by $2, but in this case, it's simply a 1. So 20 plus 1 times 4. So I'm going to put a little 4 here, and I'm going to do that calculation and realize, hey, $24 is the best price for these to make the most amount of money from these ticket sales. How many tickets will be sold? Well, unfortunately, 100 students will then not buy tickets because it's too expensive for them. But it will be 700 minus 25 times 4. 700 minus 100 is 600. So how many tickets would be sold? You're only going to be selling 600 tickets. Okay. And then the last question, how much money? If you charge $24 and sell 600 tickets, this is where we get that max revenue. We can make $14,000 $400 given this scenario. Okay, so it'll be just like that on your quiz. You just have to read the words, translate the words into two linear situations, which you will then multiply together, and that's what makes it quadratic. Okay, here is our classic dropping an object. I will give you this formula. Okay, I will tell you what it is. This is your height, your current height, based on negative 16t squared plus whatever this number. This number will be different on your quiz. Okay, depending on the version, I change the numbers around, but it doesn't matter what the numbers are. So for the first thing we want to do is we want to see what the height. How far did it drop after 2.5 seconds? Okay, so we want to know the current height, how far off the ground it still is after falling 2.5 seconds. Well, that's a real easy calculation. It's negative 16 times 2.5 squared plus 188. Okay, there's two ways to do this. You can simply just do it at your blank screen. You can type in 2.5, you can square it. So I have my negative 16. I have how many seconds I ask you about. Maybe on your quiz it'll be 3 seconds. Doesn't matter, whatever that number is, put it in for your t, and then plus, in this case, 188. Calculator tells me it is 88 feet above the ground at that point. Okay, so another way you could have done this is go to the y equals screen, type in negative 16x squared, and then depending on your version, in this case it's 188, but depending on what your number is, this will be a different number. So now I could look for 2.5, which I currently won't see because my table skips over the 2.5. But remember, second windows, I can have my calculator tell me after 2.5 seconds, we can see that same answer, 88. Okay, so two ways of doing it. I don't care how you do it, but then you will then have to tell me when it's going to hit the ground. So if you use your calculator, you can estimate when it's going to hit the ground. I know it's going to hit the ground shortly after 3 seconds. So because at 3 seconds, it's still 44 feet off the ground. When you get to 4 seconds, it's in the ground. It busted through the ground and kept on going down. So you're solving this equation. We want our height to be 0. So negative 16t squared plus 188. You can solve this very quickly on a calculator. That 188 needs to become a negative 188. I'll show that. Negative 188 equals negative 16t squared. We're solving by the square root method. Once I subtract that 188, I need to divide by negative 16. And this is what t squared equals, okay? It's not going to take 11.75 seconds to hit the ground. I take the square root of this. So remember your shortcut, second x squared brings up the square root, and the copy and paste feature of these calculators is second negative. That's your answer. So it basically pastes 11.75 in underneath the radical. I hit enter. I feel good about this answer because we knew it was going to be a little bit more than 3. So 3.4, and we should round to the nearest hundredths, 2 decimal places. I look here, it's greater than 5, so that 2 should become a 3. That is all we are doing. Okay, so you'll see a revenue problem, you'll see a word problem involving dropping an object, but they're all done the same way. So please make sure you understand where these numbers are coming from. Last page, and this last page should be easy, should be. This section, do not get wrong. Okay, now I'm willing to go over this by hand, but you can type it into a calculator. So adding and subtracting should be easy. I need to realize, though, if I'm going to do this by hand, I am going to have to change these to their opposites. Since I'm subtracting a quantity, I need you to realize we're adding an 8. And then we're adding a 7i. So when I look at this problem, I just need to combine my like things, and I do want this in standard form. So I want, this is my only real number is an 8. So I want that 8 first. Then I'm going to put the imaginary. That's a 12i. 12i plus 7i is 19i. Okay, so that's the answer. Your choice if you want to do it on a calculator or not. Okay, that one's pretty easy to do without a calculator. So I'll show this problem without a calculator, and then I'll show you how you can do this with a calculator. Okay, so just so you don't somehow mess this up. So right here, I can multiply these together. And when you multiply these together, you're going to have negative 7i squared. Okay, remember, I squared is equal to negative 1. When I distribute, so I want you to connect that negative, and I want you to realize if you're doing this by hand, you're going to have a positive 16i, and then negative 8 times negative 5 is a positive 40. I times I is I squared. Okay, so this really means positive 7 because I squared is a negative 1. I get a positive 7 plus 16i, and then this becomes a negative 40 because I squared is negative 1. When you combine your regular numbers, you get negative 33, and then your imaginary. So you always want your answers in A plus BI mode. So A plus BI mode. So let me just quickly show and review how you can type this into a calculator. So if I see a problem on paper, I want to type this into my calculator exactly how I see it. So the first part was just a negative I in parentheses. So your I is second period. So I hit the second button, and then down here, I know the camera is not showing this, but there it is. Above the period is a blue I. That's our imaginary. So then the next part would be parentheses, 7-second period, close the parentheses. I have minus parentheses, 8-second period, close the parentheses, open the parentheses, type in a negative 2 minus 5-second period, and close it. So I just need to make sure if you're going to use your calculator, make sure you type it in exactly how you see it, and it's not going to lie to you. So I definitely want you to check your answers using a calculator. Okay, so I have no problem. You simply, if you don't want to do it by hand, you're allowed to simply type in the problem using the proper notation, 3-second period. I typed in number 13. Okay, don't mistype. You hit enter and you simply copy down, and I will give you 2 points for that problem. So don't mess it up. Now you could do FOIL. So when you check if you actually check your answer, I show the work. I always show where these numbers are coming from. I did the distributed property twice, and then I simplified to this answer. So same way with this, you are allowed to. So I'll show this by hand. When you square something, you're taking itself times itself. So again, we'll pick up a calculator. We can confirm this on a calculator, but maybe on the SATs, you would see a problem like this, and you're not allowed to have a calculator. So I want you to at least be aware of where these numbers are coming from. Negative 5 times negative 5 is a 25. I distribute the negative 5 over here. I get a 10i. Then when I distribute the negative 2i, I get another 10i. And then when I take negative 2i times negative 2i, I'm going to get a positive 4i squared. And it's your job to know, if you're doing this by hand, that I squared is a negative 1, which makes this a negative 4. So when you look at that, you have to think of negative 4. 25 plus negative 4 is going to be a 21. And then your i's become a 20i. But I promise you, in fact, I'll quickly do it because it doesn't take long to type this into your calculator. And you should have plenty of practice typing in these problems to make sure you're aware of how to do them. Okay, so that takes care of that's easy points on your test or on your quiz. Do not get them wrong. You're allowed to just type it in and show the answer. Number 15, I am making you solve this by the square root method. I tell you, the only difference is your answers are going to be imaginary. So I just want to have one problem. I didn't want to do it on the first page. I want you to be able to see a problem where now when we go to solve and we have to take the square of a negative, we just will have imaginary answers. So I do the same steps that we did on the first page. I undo, so this right here is going to be negative 100. I divide by 5, and I get negative 20. I now take the square root. Anytime you take the square root, you better have plus or minus. I need all answers. I'm reminding you that. So that clue about all answers is telling you have a positive answer and a negative answer. Since it is negative, it's going to be an I. And then I would want you to remove any perfect squares that's in your number. So in this case, 20 is not a big number. 4 fits into 20. 4 is a perfect square. It fits 5 times. So please make sure you realize I'm going to break it up as square root of 4, square root of 5. Final answer. I take the square root of 4. It becomes a 2. I prefer you type in your 2, put in your 2 first. Then this I. If you have I2, I can't mark it wrong. It just looks goofy. And then root 5. And you are done. Okay? 16 is a question that should be so easy to do. Okay? But if you didn't do your big ideas, you didn't sit down, look at the problems in our notes, this is going to confuse you. Okay? I even tell you that it's easy to solve for X and Y because I want my both sides to be the same complex number. Well, I know this side's 45. I need this to be a 45. So I simply take 45 equals negative 5x. Okay? And all we need to do to solve that is to divide by negative 5. Some of you can do this in your head. And when you divide, you get negative 9. If this x is a negative 9, negative 5 times negative 9 is 45. Each side has a 45. Then I do the same thing with the imaginary part. I need these to be the same number. So on the left, I have a negative 4i. Now, you don't have to write the I because I'm trying to get this y. You need to know what y has to be so that this then becomes a negative 4. So to solve for y, I either divide by 1/4, I could divide by 0.25, or I simply can multiply by 4. So I don't care how you do it. Negative 4 divided by 1/4, you're going to get negative 16. If you say, well, I rather divide by 0.25, I still get negative 16. If you said, well, instead of dividing by 1/4, I want to multiply by negative or multiply by 4, in all cases, y is going to be negative 16. So I'll show the work that I simply multiply by 4. Okay, but those are your answers. If this y is a negative 16, 1/4 of negative 16 is the exact same thing as this. So that's all you're doing. And then the last question on your quiz, this is a 2-pointer, and I will give you this table. Okay, in class we talked about what it means to find, looking at circuits and stuff to find the impedance of a circuit. You don't need to know anything about electricity. You just need to realize that looking at this chart, this right here, this part right here, this little part of the circuit, that is going to be simply an imaginary. This 10 is really the L, and it's going to be a 10I. So I'm thinking to myself, this is a 10I. This right here is the real part. It's going to be a 9. So far I have 9 plus a 10I. And then this right here is going to be negative. So this symbol right here, this part of the circuit is going to be a negative. So it's going to be a negative 15I. You add them all together, and that's impedance. Okay, so you have to label your parts, and everything's going to be clearly marked. I'll probably have this same circuit. And now, again, we can change the circuits a little bit, but for the most part on your quiz, it'll look just like this. And then you just have to simplify this and realize it is 9 minus 5I ohms. Okay, that's all we have to do. So it took me a half hour, just under a half hour, to explain all this. Please make sure you understand this. I would love for everyone to get a perfect on this. So if there's something that you're not sure about, please ask. We can look at additional problems in our notes. Remember, there was that extra practice from 3.1. There was a handout that I gave with 9 questions from 3.1 where you're practicing these concepts. And then with 3.2, you're dealing with complex numbers, which for the most part, our calculator can help us with. So that's what we need to do. Let's end on the marking period on a good note. I want everyone to do well on this quiz. So thanks for watching.